A key to the secrets of the brain. Hypothesis. Cerebrovascular autoregulation depending on intracranial pressure.
Hi, my name is Kola Khachataryan. I am a neurosurgeon and neuroscientist from Armenia. Now, I'm in my beautiful garden, breathing this wonderful, clear air. I'm going to perform a hyperventilation to increase oxygen delivery to my brain. Now I feel a pretty strong dizziness, which is thought to be due to hypoxia of my brain. Why? Who can explain me this phenomenon?
The modern neurology and science have many such paradoxes and controversies. Indeed, this is a paradox. Hyperventilation leads to the opposite result. Instead of increasing the oxygen supply to the brain, it leads to hypoxia, and this is a well-known fact. In 1967, Russian professor Yarulin was the first to explain this phenomenon by vasoconstriction of the brain vessels as a result of decreased carbon dioxide concentration. Others have explained the vasoconstriction by hyperventilation-induced alkalosis. Does really hyperventilation cause vasoconstriction? We have decided to study this concept. Now, we are going to perform fundoscopy with video recording of Elina's retinal blood vessels.
In order to obtain the baseline diameter of the retinal vessels, we are going to perform a video fundoscopy prior to hyperventilation. At this point, you can see the central artery and the accompanying vein without hyperventilation. Now, Elina is going to hyperventilate, which will be immediately followed by video fundoscopy. Retinal vessels originate from the internal carotid artery. Therefore, hyperventilation-induced vasospasm in cerebral vessels must also be represented here. Now we will repeat the fundoscopy. However, we don't see any changes in the diameters of the vessels. This was also confirmed by actual measurements. It is unlikely, but perhaps the hyperventilation was insufficient. Let's ask Elina to continue the hyperventilation. She will hyperventilate long enough to feel dizzy. Now, we obtain a video recording of her vessels again. Nevertheless, as in the previous recording, there is no vasospasm. As a matter of fact, the arteries even became slightly larger. Turns out that Dr. Yarulin and all of his followers have mistaken, and this mistake caused many controversies in neuroscience. In order to criticize an existing concept, one has to suggest a better explanation. Therefore, we've suggested the hypothesis of cerebrovascular autoregulation depending on intracranial pressure. The circle of Willis is a pool supplying the brain with blood. This pool gives rise to the arteries of the cortex and subcortical nuclei. Penetrating arteries supply the subcortical structures, i.e., diencephalon and basal ganglia. They have straight structure like a branch of a tree. The vessels supplying the cortex originate from anterior, middle, and posterior cerebral arteries. Before entering into the cortex, these arteries are located inside the CSF channels and are attached to their walls by thin collagen fibers. Interestingly, just before entering the cortex, they make a spiral loop. Now the concept of the hypothesis. If the ICP decreases, the arachnoidal membrane shrinks, the collagen fibers somewhat loosen, the loops become intensely curved, and the blood supply of the cortex decreases. If the ICP increases, the opposite changes occur: decreased cortical blood supply and subcortical hyperemia. This hypothesis can become a universal key which will help to unlock a number of doors into the brain secrets. This can solve many controversies in paradoxal neuroscience.
Hi, my name is Elena. I'm a 17-year-old student of Yerevan State Medical College. I don't understand how neurology can be controversial. Neuroscience must be free of any controversies, so please think of the presented suggestions.